Alright, this is a review problem, problem number 5 on the final exam review. In this problem you're given a truss. We didn't actually cover trusses per se, but really just think of this as a structure. And you're asked to find the reaction forces at the supports of the truss. Okay? Alright, so this is a statics problem, and what we know about statics problems is that we're looking for sum of forces in the x direction equals 0, sum of forces y direction equals 0, and the sum of moments are equal to 0. Okay, so 3 equations to help us resolve the forces that are involved in this statics problem. So the first thing to do is to draw a free body diagram. Okay, so we sketch this in here. Take it away from its supports. Alright. So we have this. And then because this is on rollers, this force C is in the vertical direction only. Okay. Because this is on a pin, remember pins can have forces that have a vertical component but also a horizontal component. So I'm going to draw it like that, EX going to the left. Okay, then we have our forces of 500 newtons applied here and here. Okay, so we know some dimensions of the problem, and actually the way this thing is sketched, it's implying some symmetry to the truss. Okay, so we're going to use that symmetry. So this is 12 meters, this is 12 meters, this is 12 meters, and so we can later use these dimensions to try to, figure out the reactionary forces. All right. So sum of forces in the x direction, where x is positive, is going off to the right. Okay, so I look at this free body diagram, and I see that the only time I have a force in the x direction is at EX. So what we know is EX is equal to 0. Okay, next we can look at sum of forces in the y direction, where y is referenced to be up. Alright, and so starting here we have the 500 Newton force going down, we have this 500 Newton force going up, we have EY moving up, and we have C. The way I've referenced this C is moving up. Okay? And all that is equal to 0. Alright, so the catch is we have this equation, and there's 2 unknowns. We need another equation, and we've talked about this in class, that we look at the sum of moments and have those sum to 0. Okay? Sum of moments around any point. Alright, so let's use the point, it doesn't matter. Let's use the point C. Okay, we can use E if we wanted, but let's use the point C. And what I see here is a moment generated by this direction perpendicular to this force. Okay, so that total length is 12 plus 12, so 24 times 500. And this causes a counterclockwise rotation, which we use as the positive sign for moments. Okay, so that takes care of that 500 Newton force. Okay, next we want to look at the lower 500 Newton force. All right, and so remember, forces can act along a line of action, so we extend this up. It's as if this were applied right here, and I look in the perpendicular direction. So let me use a different color for that. Perpendicular direction to the 500 Newton force, that is this length, the green line. Okay, so from the symmetry of the problem, we know that this would be 6, because this is centered halfway along the 12 meter base of this triangle. So here's 6, there's 6. And so we can get this total length. That would be 6 plus 12, for this moment arm, shown in orange, okay, with this force, okay? That would cause a clockwise rotation, which we put as negative, so minus 18 times 500 would be the moment generated by the second 500 Newton force. Okay, we know Ex is 0, so next we look at the force generated by the moment from Ey. All right, so again, moving this Ey along a line of action, let's use a different color, let's use pink. So Ey, extend this up till we hit, the point perpendicular to C. Okay, so this pink line, this distance is 6. All right, so that moment would be Ey times 6. And again, this would cause a clockwise rotation, and so this would have a minus sign on it. Okay, and that does it for all the forces that are generating a moment around point C. Okay, so we have this equation. I can move Ey6 to the other side, and then sum the forces over here. I have 24 minus 18, which is 6 times 500. The 6's divide out, and I see that Ey is 500 newtons moved in the reference direction, which is up. Okay, and so from there we just need to find the reaction force at C, and we have this equation. We can plug the 500 in here, and from that we get minus 500 plus 500, those cancel. 500 plus C equals 0. That means that C is equal to minus 500 newtons. Okay, so that's the same thing as 500 newtons referenced in the opposite direction. In this case, that would be down. Okay, so there's a statics problem. I expect you to know sum of forces equals sum of forces in the x direction is 0, sum of forces in the y direction is 0, sum of moments about any given point is 0. Write the equations and then solve for the unknown variables.